Okay, so we're going to go ahead and start lesson 1.2 today. This is all about finding angles, which mostly is going to be the definitions that kind of go along with angles. And again, making sure that we really have that specific meaning for geometry. Again, you've probably heard of things like angles before, but making sure that we know in geometry what specifically that means when we say the word angle. Other than that, again, that's what we're working on today. Kind of learning the notation of how we show angle measurements and how we show that angles are congruent and things like that. And then also talking about how to measure an angle. If you don't already have one of these, you're going to want to get, there we go, a protractor. I will put one that you can print off and cut out on the resources link on Canvas if you don't have one. But something like that is probably going to set you back a grand total of about 50 cents if you go to a store. So it's definitely something you're going to need this year. Okay, so there's our vocabulary words here. A couple of those are going to be more important than others, but we'll probably stay away from incoming angle and outgoing angle, but the rest of those you're going to need. Okay, so take a quick second here. Think about that question. You've got two clocks, basically a watch and then Big Ben in London. And the question is the angle between the two hands of the wristwatch similar to the angle of or smaller than the angle between the two hands of the clock? And explain how you would know or why not. Okay, so even though the wristwatch is a whole lot smaller than the clock, in this case, those have the exact same angle. It's the same time showed on both. The angle is the same. It has nothing to do with how big the actual shape is or how long those little lines are. It's the number of degrees between the two angles, and we'll talk more about that as we go. Just an example of using some angles. Any of you play pool, you definitely need to know your angles. Okay, so here's our vocabulary words, kind of the biggest ones today. Oops. And that is going to be that an angle right there, can't click on this, can I? Is formed by two rays. We talked about rays yesterday, so there's ray AT and there's ray AP. Together, those are the sides of the angle. They come together at a vertex, which is point A, and together they create an angle. Now, when we name an angle, we can do this two different ways. We can either name it angle TAP, or we can name it angle PAT. The big thing there is there are three letters, and that middle one has to be the vertex. If you see that A is always in the middle. And the way we write that is angle TAP or angle PAT. We'll talk about this part here a little bit later. We could simply call this angle A, but there's some restrictions on that. You can't always just use one letter. So if we wanted to name all of the angles in this drawing, there's a couple of different things that we could do. First of all, if I wanted to name an angle like this one here, I could name it something like UTV. Again, making sure that vertex is in the middle. UTV or VTU. Now, in this case, because it's not going to be confusing if I just said angle T, there's only one angle there. I could just call this angle T. That would be fine in this case. But if I went over here, for example, I couldn't call any of these angle A because I don't know which of them I'm talking about. Is it this one? Is it that one? Is it the whole thing? So in this case, I need to use three letters. Angle XAY or angle ZAY or even angle XAZ. Those are all three different things, and I need to be able to tell them apart. So I can't just say angle A. The last thing I could do is I could say something like this. If there's a little number in there, that's letting me call this angle 1. And I'm perfectly fine if you have a picture or something that you could just add those numbers in to help refer to them. But obviously on like a test or something, if the answer, if they're not in the picture, the answer is probably not going to be the number because they're not there. Okay, next up, we've got the measure of an angle. And so the measure of an angle is where we'd actually get out our protractor and measure it in what we call degrees. So the measure of an angle is the smallest amount of rotation from one ray to the other. And so you'll see here we've got this angle GPS. and its measure is 136 degrees. When I ask for the measure, that's always going to be less than 180 degrees, which is your, like a straight line is 180 degrees. If we want to talk about the other side of this angle from here to here, that is called the reflex measure of the angle. It's the same angle, it's just going the other way around. And in geometry, we're not going to use that reflex angle very often, but in real life, of course, that might be useful to talk about turning one direction versus turning the other direction. But for us, most of the time, we're asking you for the measure of an angle, which is always going to be less than 180 degrees using your protractor. So here's some steps for using a protractor. I think I need to move my camera out of the way so you can see that. Biggest things here, you always have to start by placing the vertex of your protractor on the vertex of the angle. So if you can see my protractor there, can you see that? There's a little hole there with a plus sign around it. It's kind of hard to see, but that's where you put the vertex of the angle. Next step is to line up the 0 mark with one side of the angle. Now you can see most protractors have a 0 on both sides. You can use either one, but whichever 0 you line up, you're using that scale. So if we lined up the 0 on the inside scale, we're using the inside scale. If we had lined up the 0 on the outside scale, we'd be using the outside scale. So this angle is about 34 degrees, not 146 degrees. So when you measure it, make sure you're reading off the correct scale. Okay, so at this point, I'm gonna have you pause the video and try to measure those angles. You're gonna have to just kind of put your protractor right up on your screen there, measure those angles, and then there'll be a question to answer before you move on. Okay, so I'm gonna go ahead and switch over here so we can see the protractor. So hopefully you can see that. We'll start with angle 1, measuring that. The biggest things here, let's zoom in a little bit. The first step, remember, was to line up your vertex with the mark on your protractor right there. The next step would be to line up the 0 mark on your protractor with the first ray. So you can see right there, I've got my center mark lined up at the vertex, my 0 mark lined up there. Now I can read it off. Because I use the inside scale, I'm using the inside scale. There's 10, 15, and I can kind of use these littler marks on the outside to say, well, it looks like I'm about 16 degrees there. Now, if I want to do the same thing for angle 2, this time you'll notice that when I line up my 0, it's actually on the outside scale, right? The 0 there is the outside scale. So I'm following my outside scale along all the way around my protractor. And you can see that right there. It's going to be a little bit past 160, maybe like 162, 163 degrees. And then this last one is going to be the hardest one for most people. I'm going to flip my protractor over here because it's kind of that way. Put my 0 on there. And you'll notice this one's really close to 90. And so the question would be, is it 88 or is it 92? And the way you're going to tell the difference is, again, by looking at which scale you're on. So I lined up the 0 on the inside scale. If I follow the inside scale, I've already passed 90. So this has to be 92 degrees, not 88 degrees. On ones like this, pretty obviously bigger than 90 degrees. On one like this, pretty obviously less than 90 degrees. But for something like number 3, you have to trust the scale on your protractor. Are you on the inside scale or the outside scale? And that matters of which one you lined up at the 0. Okay. So you can see there, 16, 164, and 92, which is about what we said, right? Okay. Next up here, we've got 2 big ideas on this slide. The first one being the word congruent. Congruent means basically the same thing for angles as it does for line segments. Congruent angles are going to have the exact same measurement in degrees. And so we show congruent angles in a picture by using this little tick mark. You kind of see that they put that arc through there and then a tick mark, an arc through there and a tick mark. So they both have one tick mark, they're congruent. Same thing with lines. If they both had 2 tick marks or 3 tick marks, those would be congruent as well. And then really quickly, this is, again, pretty important. The angles angle DOG and angle CAT can be congruent. The measurements of those angles, though, would be equal. When we say measure of angle DOG, we're talking about a number, 40 degrees. When we say angle DOG, we're literally talking about this thing. It's not a number anymore. And then the last thing here we've got is an angle bisector. In this case, in order to bisect an angle, it'd have to be a ray or a line or something like that. And that means, if you remember from the last video, bisect means to cut into two equal pieces. And so if ray CD is a bisector, that means that these two pieces there and there have to be equal. The angles themselves would be congruent. And so if you look in here, are any of those angle bisectors? And it turns out there's only one angle bisector that I see in here, and that is ray RP. It's the only one that splits it into two equal pieces. Right? This one's not quite. They're different. And this one, even though these are equal, it's not bisecting the angle. It's not cutting into two pieces. It actually cut it into three, and only two of them are actually equal. So RP is a bisector of angle SRQ. Might be useful to see that written out. So in order to say that, we'd say something like ray RP bisects angle SRQ. That'd be how we'd write that in math. Okay. Hey, you can see it right there. RP bisects angle SRQ. Okay, and then our last thing here is angle addition. Angle addition works just like segment addition. All it says is if you have a situation like this, that piece plus that piece equals the whole thing. So here's an example. You have a slice of pizza with an angle that measures 140 degrees. That's that angle there. Your friend wants to share it with you. She cuts through the vertex into two slices. You choose the slice that measures 60 degrees. How many degrees are in the other slice? So think about that for a second. Now, this one's not addition. This is actually subtraction. You're kind of thinking what plus 60 degrees is going to make that whole 140 degrees. And that means that the other person, your friend, got the 80 degree piece. If you can add, you can subtract too. Although they wrote an equation and solved that, but you could always just use subtraction. A couple of summary questions, and then you can go take a look at the practice. So I'm going to let the video pause here, and I'm going to let you think about that for a second, and then we'll talk about them. So what does it mean why does the definition for angle specify smallest measure? Why do you think that is? Basically there, we just need to agree on which one it is. There's always going to be one that's less than 180 and one that's greater than 180. And so we decided the less than 180 one makes the most sense. And we all just have to agree on that. What does it mean when we say two angles are congruent? It means they have the same measure. And what does if and only if mean? If and only if means that they're basically the exact same thing. The example being congruent and equal. Angles are congruent if and only if they have equal measures. They're not the same thing exactly, but they're essentially the same thing. There we go. Okay, one more example here, I think. Find the measure of angle RTX. So there's R, T is the vertex, and X. Okay, so hopefully you realized you weren't finding this little angle here. That would be RTS. If you found that angle, you still had to add the 120 to it. And so we get 136 for the whole thing. And the way you're able to figure this out is we need to know that that whole way around has to be 360 degrees. So if I were to take 360 degrees minus 135 minus 62, 163 is what's left there. Okay, so that's going to be everything for today. Go ahead and look at the practice problems that you have there, And then I think tomorrow we should have some time during our Zoom meeting to do some examples, maybe ask questions, make sure we're doing things. Got a chance to ask everything that we want to know about these angles. And then, yeah, this should be a video you're watching on Monday, I believe. And then Wednesday we'll do sections 1.3 and probably 1.4. I'll see you tomorrow. Maybe, if I can figure out how to turn this thing off right now. How do I stop you?